Alright, so we are already done with those few couple sections of chapter 6, and now we're talking about chapter 7. And we're going to start by 7.1, which talks about angles of polygons. And so far we've talked about talked a lot about triangles, right? And we talked about the properties and the theorems that have to deal with triangles. Triangles, they have three sides, three angles. The sum of their angles equals 180 degrees. So let's talk about what the measure, so the sum of the measures of the interior angles of a polygon. Now, polygon is basically just like a shape, enclosed shape with multiple sides. And so polygons is like a square, or it could be a pentagon, so on and so forth, with n amount of sides. So n could be anything. Um, so let's talk about how we can find the sum of the measures of any polygon. So first of all, let's analyze what we've learned so far. So first of all, we have the triangle right here. And the number of angles that a triangle has, we know to be 3. We have 1, 2, and 3. And the number of triangles, whenever you see this here, how many triangles are in a triangle? And that is just 1. You can make only one triangle out of one triangle. And we know that the sum of the angles is 180. So we knew that from the previous unit. So now we have a square, or I guess we could say square, rectangle. This could also be like a trapezoid. I am losing my. I can't think of the right name for it if that's wrong. But in any case, for any sort of polygon with four sides, I guess I should say that four sides, and here's three sides. So the number of angles that this has is 4. Number of triangles. So here's the thing. So if we go from the vertices or the vertex of this square or this four-sided polygon, I could create two different triangles right here. I can't do that by drawing a line from any other vertices, because drawing a line right there, that doesn't create a triangle. From here, it doesn't create a triangle. If I do one here, that creates a triangle, but I just then it would just count as that. So I can create two triangles. So there's number of triangles in a square is 2. So let's see what this adds up to be. So I know that this is 90 degrees. I know that this is 90 degrees, so these are right angles. So if these are right angles, then I know that this is 45, this is 45, this is 45, and this is 45. So basically, the sum of both triangles, the sum of the angles of both triangles, will give us the sum of the angles of the square. And so this can work for any four-sided polygon. So that means the sum of two triangles, and we already know that the sum of one triangle is 180. So the sum of two triangles would be 2 times by 180. So you see here that we have one triangle. I guess I should write that more consistently. So here, if I have one triangle, like right here, I have 180. Here I have two triangles, so I do 2 times 180, and I get 360. That's the sum of the angles of a four-sided polygon. Now let's talk about a five-sided polygon. So what I did over here was I created triangles. So we do this by taking the diagonals of a polygon. And the diagonals of a polygon is whenever you take a line segment, so from one vertex one vertice to another, but it can't be adjacent or consecutive. So here is a consecutive vertice. Here, over here, is a consecutive vertice. So a diagonal means I have to draw it from the vertice, but to a non-consecutive vertice. So there, and there, right? I can draw another diagonal. So this is what we call diagonals. Excuse me. Diagonals. So that's this right here, and that's this right here. These lines right here, these are diagonals. And you can see that from doing this, creating these diagonals, I create triangles. So here's one triangle, two triangle, three triangle. And I have 5 angles total. So 5 angles. Here's 1, 2, 3, 4, 5 angles, and I have 3 triangles. Now, if I were to take the sum of this angle, this angle, this angle, this angle, and this angle, and this angle, this angle, this angle, this angle, you can see that I'm just adding up all the angles of the pentagon, of all the triangles, which happens to be the sum of the angles of the 5-sided polygon. This is 5 sides. And so that means all I have to do is do 3, because I have 3 triangles, and multiply that by 180. And when I do that, 3 times 180, I get 540. So I hope that you guys see a pattern here. Notice the pattern right here. Okay, that 180 is consistent every time we are trying to find the number of the sum of the angles in a polygon. We're multiplying by 180. Now this number right here on the outside, notice that this number is always 2 less. Excuse me, 2 less. You notice here that it's 2 less, which is this number right here. 2 less. This number right here. It's 3 is 2 less than 5, 2 is 2 less than 4, 1 is 2 less than 3. And so that brings us to our theorem, which is the Polygon interior angles theorem. So the sum of the measures of the interior angles of a convex n-gon is n minus 2 times by 180. So n right here, excuse me, n is the number of sides. Okay, and so that this tells us the how to find the sum of the angles of any polygon, convex polygon. So going to this example right here, it says find the sum of the measures of the interior angles of this figure. So first of all, let's count how many sides we have. So starting here, we have 1, 2, 3, 4, 5, 6, 7, 8. So this is a octagon, kind of. It's kind of long, but anyways, doesn't have equal sides. But so this is 8 sides. So n is equal to 8. Alright, so now we just have to use our equation for number of, or the sum of angles, which is n minus 2 times by 180. So here we know that n is equal to 8, so n minus 2 times by 180, and that's equal to 6 times by 180. So 6 times by 180, and that is equal to 1080. So that is the sum of the measure of the interior angles of this figure right here. Okay, let's come down here. So finding the number of sides of a polygon. So here it says the sum of the measures of the interior angles of a convex polygon is 900 degrees. So I know that the sum is 900 degrees. So let's use our equation. So I know n minus 2 times by 180 is equal to 900 degrees. Now can I find the number of sides of this polygon? So here I can just use algebra to find the number of sides. So I could distribute this 180 in here, so I get 180n minus 360 equal to 900. I could add 360 to both sides. So then I get 180n is equal to 900 plus 360. So I get 1260 divided by 180. So then I get n is equal to 7. There you go. So we can find the number of sides. So we're just using this equation right up here. Using this equation to help us solve for both the sum of the measures, and also we can use it for sides depending on we can find the number of sides depending on the information that is given to us. Okay. So now let's come here. So finding the unknown interior angle measure. So first of all, we know from up here, so well, first of all, this is a four-sided polygon. We have 1, 2, 3, 4. And any four-sided polygon, as we talked about right here, any four-sided polygon will have a sum of 360 degrees. So here, if I take up all the angles, so here's 108 plus 121 plus 59 plus x, I know that this is going to equal 360 degrees. So let me add up all this right here. So 108 plus 121 plus 59, and I get 288 plus x is equal to 360. Subtract 288, and then I get x is equal to 72. Okay, now let's move on to this next concept. Now this concept is talking about the exterior measures, so using exterior angle measures of a polygon. So unlike the sum of the interior angle measures of a convex polygon, the sum of the exterior angle measures does not depend on the number of sides. So it does not depend on the number of sides of the polygon. The diagram suggests that the sum of the measures of the exterior angles, one angle at each vertex of a pentagon, is 360. In general, the sum of 360 degrees for any the sum is 360 degrees for any convex polygon. So you can see that in these diagrams right here. So they're taking this left angle of this left side exterior angle, and this left side exterior angle, and then this side, and then this side, and then this side, and they're taking them, adding them up, and it actually makes up 360 degrees. Now, this doesn't just work for any five-sided polygon. This theorem right here tells us that it works for any polygon, n-sided polygon. So the number of measures of an exterior angles of a convex polygon, one angle at each vertex, is 360 degrees. So it doesn't matter about the number of sides, like the polygon interior angles theorem doesn't care. The number of sides doesn't care. So the exterior polygon exterior angles theorem is just always 360 degrees. So coming down here to example 5, finding an unknown exterior angle measure. So here's a 1, 2, 3, 4-sided polygon. But since we're talking about the exterior angles, that's kind of irrelevant, because what we know is that the exterior angles at one of the exterior angles, so you have to make sure that you're using one of them, not all of them, is going to be equal to 360 degrees. So we know that 360 is equal to, we could say 2x plus x plus 89 plus 67. So then simplify that, we get 3x, and then when we add those two terms together, we get 156. Here I can subtract 156, subtract 156. So 360 minus 156, that's should be 204. So 204 is equal to 3x. I can divide by 3. And x should equal 68 degrees. So that's not saying what these angles are equal to. It's just saying that x is equal to that. So yeah, this one would be 68, and this one would be double 68. All right. Let's move on to this last example here. So finding the angle measures in a regular polygon. So the trampoline shown is shaped like a regular decagon. So that's actually a 12-sided polygon, dodecagon. So you can see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright, find the measure of each interior angle. So we're going to find the measure of each interior angle. Now, so since we're using the interior angles, we need to use the formula that we had. So we know that n is equal to 12, so we do 12 minus 2 times by 180. So that should be equal to 10 times by 180, and that should be equal to 1800. Now, that's the sum of the interior angles. Now we want to know the measure of each interior angle. And so since there are 12 angles, all I need to do is to take the sum, divide by 12, and all of these are going to be equal because a dodecagon should be all the sides should be equal. So which means the length should also, the angle should also be equal. But 1800 divided by 12, so it's equal to 150 degrees. So that's the measure of each angle inside. Okay. Now, since we know that one angle, now we need to talk about the exterior for B. So the sum of the exterior angles of one angle should be 360. So because there are 12 exterior angles, then what we can do, so again what we're trying to find is, so here is a exterior angle, so like right there, and then we can do it again. So right there is another exterior angle, and another, so we're trying to find the measure of each of these right here. So for B, again, we know that there are 12 of them, and we know that the sum is 360 degrees. So I can do that divided by 12, and I'm going to get 30 degrees. So the measure of each exterior angle in the dodecagon is 30 degrees. Okay. So that should pretty much do it for this lesson. Really pretty simple angles of a of polygons. So if you have any questions, just make sure to email me, or I will see you in class.